Have you ever been on a project that just seems to drag on and on, blowing past every single deadline? It's a huge source of frustration, right? But what if I told you there's a systematic way to predict a project's finish line with almost perfect accuracy? Well, turns out there is, and that's exactly what we're going to break down today. So, what's the secret? How do engineers build a skyscraper or scientists land a rover on Mars with schedules that are planned right down to the day? It isn't magic, I promise you. It all comes down to a super powerful technique called critical path analysis, and it's what turns the absolute chaos of a project into a clear, predictable roadmap to success. All right, so here's the game plan. We're going to walk through these 6 steps together. We'll start by taking a messy to-do list and giving it some logic. Then we'll build a visual map of the project, run some simple calculations to find our wiggle room, and finally, we'll uncover that all-important critical path and see why it's such a game changer. Okay, first things first. Before we can even think about a schedule, we gotta know what we're actually doing. This first step is all about bringing some order to that giant, chaotic to-do list that every project starts with. So the first tool in any pros toolkit is the work breakdown structure, or WBS. Seriously, think of this as the concrete foundation for your entire plan. You take your big, kind of scary project and you just smash it down into smaller, bite-sized pieces called work packages. And here's the most important part. A work package isn't just a task. It's like a mini project all on its own, with details on the work, the time, the budget, and who you need to get it done. Let's make this real. Imagine our project is a simple charity bake sale. Our first to-do list might just be a jumbled mess, right? Bake cakes, design flyers, book a spot, sell tickets. The WBS forces us to get organized. We create a work package for bake cakes, and we estimate, okay, that'll take about 4 hours. We make another for design flyers. We'll say that takes 2 hours. See what's happening? We're turning a vague wish list into a structured plan with actual estimates. This is step 1. Moving from total chaos to having some control. All right, now that we have our organized list of tasks, we need to figure out the sequence of events. You can't bake a cake before you buy the ingredients, right? It's just common sense, and that's where building the project network comes in. So how do we visualize this? We use something called an activity on node diagram, or AON. Now, I know it sounds super technical, but trust me, it's basically just a flowchart for your project. Each box or node is one of those activities from our WBS. And the arrows, well, they're not just there to look pretty. They are crucial. They show us the logical flow and the dependencies between every single task. This whole thing really boils down to 3 key relationships you need to get. A predecessor is a task that has to happen first. A successor is a task that comes after. So in our bake sale, plan menu is the predecessor to buy ingredients. Easy. And then you have parallel activities, stuff you can do at the same time. You know, we could be designing flyers while someone else is calling around to book the venue. So when we map out all our bake sale tasks and their dependencies, we create this logical network. Now, on a real project, that network gets plugged into a tool, and it's probably going to look a lot more like this. Yeah, I know, it looks intimidating. But the principle is exactly the same. It's just a visual way of showing that you have to plan the menu before you can design flyers or bake cakes. This visual map is the key to everything else we're about to do. Okay, so we've got our map. Now it's time to put some numbers on it and figure out the timeline. And we do this with a bit of simple math, using 2 cool techniques, the forward pass and the backward pass. The forward pass is exactly what it sounds like. We literally move forward through our network map, from the very first task to the very last. And as we go, we calculate 2 things for each task: its earliest start time, the ES, and its earliest finish time, or EF. This is going to tell us the absolute best case scenario for our project's timeline. And the rules here are actually pretty straightforward. You always start the first activity at time 0. Easy enough. From there, the earliest finish is just its early start time plus however long the task takes. The next task can then start as soon as that one is done. The only place it gets a little tricky is at a merge. That's when a bunch of tasks all have to finish before the next one can start. In that case, you just have to take the biggest of the finish times because everything has to be done before you can move on. All right, so once we know the earliest our project can possibly end, we flip the script. We do a backward pass. We start at the finish line and work our way all the way back to the beginning. This time, we're calculating the late start, or LS, and the late finish, or LF. This is how we find out our real deadlines. And even more importantly, where we have some flexibility. And again, the rules are basically just the reverse of what we just did. You start at the very end of the project and you set the last task's late finish equal to its early finish. Then you just work backwards, subtracting how long each task takes to find its late start. The one little twist is for something called a burst activity. That's when one task kicks off a bunch of others. In that situation, you have to take the smallest late start time from all the tasks that follow, just to make sure you don't accidentally delay one of those paths. Okay, here we go. This is the moment we've been building towards, the big payoff. We did all that math for a reason, because with that information, we can finally find our project's hidden flexibility and its most important, unbreakable chain of tasks. This flexibility has a name. It's called slack, or sometimes you'll hear float. It's basically the amount of time you can delay a single task without pushing back your final deadline. It's the wiggle room in your schedule. And the formula? It's dead simple. Just late start minus early start. That one number tells you everything. And here's the key insight. Not all tasks are created equal. In our bake sale, a task like book venue might have a few days of slack. So if the venue manager gets sick for a day, no big deal. The project is still on time. But a task like bake cakes might have zero slack. It happens right before the final event. Any delay there, even just 1 hour, is going to push back the entire bake sale. And that chain of activities, the one where every single task has zero slack, that, my friends, is your critical path. When you look at a complex chart, it's the one path of tasks where the early start and late start times are exactly the same. This path is literally the backbone of your project. The time it takes to complete this path is the shortest possible time your entire project can be finished. So, why? Why did we go through all that work? So what? Why does identifying this one path matter so much? Well, this is where all that theory turns into an incredibly powerful tool for actually managing a project. Understanding the critical path changes everything. For one, it tells you the absolute shortest time your project will take, period. It also acts like a laser beam, focusing your attention on the tasks that absolutely cannot slip. If a task on the critical path is delayed, your whole project is delayed. There's no escaping it. This means if you're running behind, you know exactly which tasks you have to speed up. It lets you go from just managing a list to strategically steering your project toward the finish line. In the end, it all comes back to this simple definition. A project is a complex, one-time thing. It's not business as usual. It's always constrained by time, by money, and by the people you have available. And the critical path method? Well, that's the tool that helps us wrestle with all those limits and actually win. So now you have the power to look into the future and predict your project's exact finish line. But I want to leave you with a final thought. What happens when that date just isn't good enough? What do you do when your boss says you need to get there sooner? Well, knowing your critical path doesn't just tell you the timeline, it tells you exactly where to focus your efforts when you really need to speed things up.